In this problem we have exponential functions whose integrals we want to find, and we will first of all recall that if we have the derivative of an exponential, something like 2 to the x, that becomes the natural log of 2 times 2 to the x. So we know that if we see something like the natural log of a base times the base to a power, the same base to the power of x, then we know that the integral has to be 2 to the x. So for example, in letter A, we know that the integral of natural log of 4 times 4 to the x, what did I have to take the derivative of to get that? Well, it had to be 4 to the x. Of course, we could have had a constant, because when we differentiate, the constant would have gone away and we wouldn't have known. Now, what if you would just have 4 to the x? In other words, I can't just take the derivative of 4 to the x and not get a natural log. So we have an equation set up here, and what we can really do is we can say, well, if we divide both sides by the natural log of 2, then we get 2 to the x over the natural log of 2 equals 2 to the x. So what did I just prove here? Well, I proved that if I take the derivative of 2 to the x over the natural log of 2, I get just 2 to the x. So that means if I undo this guy right here, I should arrive back at this. So for example, here, if we integrate 4 to the x, so here's what I'm going to say. I'll write the integral of 2 to the x dx must be 2 to the x over natural log of 2, because we're working backwards. So the opposite of this is this. Now, in this case, we're going to end up with, probably you can notice the pattern, 4 to the x over the natural log of 4 plus c. Simple as that. Now in part C, we're going to factor out the 2 first, because that's a constant. I can ignore that for just a moment, factor it back in later. And now I see that I have 7.3 to the x. So that's going to end up being 7.3 to the x over the natural log of 7.3. Got to multiply by my 2 still. Be careful, you can't combine 2 and 7.3 via multiplication, because you do exponents before you multiply, plus a constant. Okay, and finally part D. So here we have a bunch of functions staggered together. It might be a little easier to break this up. So I'm going to treat these as 3 separate integrals. I'm going to factor out any constants that I have. Like here I have the 2, so I'm going to pull that out. 2.4 to the x dx minus 17 times the integral of 1.1 to the x dx. Following similar patterns, this guy is going to be 7 to the x over the natural log of 7. Now keep in mind, you don't need to add a plus c for each one of these, because in the end it's one constant, and it doesn't really matter whether you list them 3 times or whether you just do 1 plus c. Minus 2 times 2.4 to the x over the natural log of 2.4, minus 17 times 1.1 to the x over the natural log of 1.1, and then plus our arbitrary constant.